G'day there. You're watching the Aussie BIM Guru, and today we're covering a pretty interesting tutorial on a tool that I only actually really built for the first time quite recently, and that is how to bulk reload families from a directory to a project using pyRevit. So pretty fun. So today I'll be using Autodesk Revit 2022. I will be using Notepad++, although I do use PyCharm. These days when I'm generally working in Python, it's just a bit of a cluttered interface for YouTube, but for now I'll just keep in Notepad++ to keep things simple. I'll be using pyRevit today and also IronPython as my chosen dialect. If you haven't already seen some of my pyRevit tutorials or my Python series, you'll probably need to see these before you really understand what I'm doing, so feel free to check those out if you've got time. So today I'll be covering firstly how you can just basically configure and set up the tool for pyRevit to receive, and then we'll be looking at developing the tool itself. So in this case, I'll be firstly getting all the file paths from a directory that represent a Revit family. I'll then also be matching those paths to the equivalent families in the project to find which ones can be reloaded. And from there, just presenting a list to the user, and then we'll finally reload the families themselves. So as always, if I'm talking a little bit too fast, feel free to slow the video down. If I'm talking too slow, you can speed me up. I know most people find I talk a little bit too fast, so hopefully that's a good option for you. Without further ado, let's jump straight into Revit. So effectively, I'm just in a sample model, and I'll be trying to reload families. Now, of course, you can reload families typically by right-clicking them, and if you're lucky, they might remember where they came from originally, assuming they came from an accessible path. In this case, I can see that this is going to reload a two-door cupboard, which I can then reload. And usually you won't get any message if the family is up to date. But let's say that this family has changed. Maybe this has been deleted. So you might also get a message sometimes as well. And let's actually make another change here. Let's modify maybe actually there's probably nothing, there is actually a light in here that's nested. So let's modify the light as well, and then load this back down into the cupboard, and then load the cupboard back down into the family. So we're going to see two dialogues in this case that you might be familiar with. The first one is going to recognize the family has changed. Would we like to override it, and would we like to override its parameter values as well? For now, I'll just say override existing version. It'll also recognize that the light inside this family is different to the one in the project because it's a shared family. So we have the same option here. We can say, would we like to use the same component that in this case exists within the family itself, or we would like to use one in the project? And also, would we like to overwrite its parameter values, or we just like to reload the family itself? I'll just use the same existing subcomponent family in the project, and then we'll reload like that. So one thing in this case that is bypassed is, of course, I did reload in all the types. The method today won't address excess types in the model, but you can, of course, just run a purge unused after you've done a batch reload to get rid of redundant types. So how are we going to do this in Python? Well, there's a few steps we're going to need to do here. I might actually just begin by configuring a tool. I do have a copy of the tool with the intended function that we're going to provide. In this case, we're going to click the load button. We're going to target a directory. This is my library. It's going to scan the directory. It's going to give us the option to deep search to go to all subdirectories, which we want to do. And then it's going to show us all matches found in the project. Finally, we can pick what we'd like to reload. It's going to reload the equivalent families from that directory to the project in bulk from whatever path they happen to be found at. And we can see that we're also just effectively achieving the same outcome, whilst also bypassing some of those messages for each family along the way. So let's get started in actually building this tool. The first thing I need to do is actually configure my script to be received. So first of all, I'm just going to copy a bundle file from bulk load, and I'm just going to quickly reconfigure this just to give it a slightly different name. I'll just call this testing. And we can see that this is a bundle file, a .yaml file with a title, a tooltip, and an author property, which is what will be displayed in pyRevit. For now, I'm going to leave out any icon. I'm just not going to give it an icon. But I also need to tell my tool, in this case, that it needs to actually appear. Now, I think in this case, I've got a panel, so I don't know. I probably don't actually have to tell the panel to show these. I think it automatically shows them all if I don't provide a bundle. But it will just pick an order by consequence of their names, I believe. But that's okay, we can work with that. You could also reconfigure and reorder the bundle, or reorder the buttons using a bundle file. I've done this in a few other videos in the past. But we can see now we've got our testing button that currently does nothing. So let's begin. So like any typical pyRevit tool, I'm going to begin just by importing the necessary libraries from pyRevit. So I'm going to say import libraries, and I might zoom in just a little bit for now. So I'm going to say from pyRevit, import, and we're going to use the usual Revit, DB, script, and forms. I'm now going to prompt the user to choose a directory. So we're going to use a form to do this. And we've used these in a few past videos, so I will skip going to pyRevit to look at it in detail, but we're going to go forms, pick folder, so with an underscore between pick and folder. So this is built into pyRevit. And I'm just going to say the title is choose a directory. And for now, we're going to specify owner is none. I don't believe we have to specify the process that owns the directory. I think we probably technically could leave it out. I could try that, I guess, and see what happens. But now when I hit this button, it should prompt us to pick a directory. And there we go. I can pick a directory. And now what would have happened in this case is that directory would be stored to a directory path variable. If I cancel out of that, I will want to cancel my script. So I can also say if not directory path, so if the user hits cancel, then we can just exit our script at that point. So if I just say here, print proceed, just to show that we've reached that point in the script, but I cancel out of my script, then we can see, as always, we're going to stop our script. It's not going to run any further. If I pick a path, then we're going to see proceed. So we can see in this case, we're able to set up conditional logic to process various stages in our script and only go as far as we need to. The next thing I'm going to do is specify to the user that they should specify whether they'd like to scan just the root level of the directory that we're targeting or all the subdirectories. So I'm going to give them an option to pick this. So I'm just going to say that I want to choose a run mode for the script. And I'm just going to make a sub message just so I don't have to write it out on a really big line. I'm going to say in this case, choose carefully, large directories can take a while, because you might be targeting a very, very large set of subdirectories, for example, a whole server. So you do want to warn the user just to think carefully and make sure that they actually want to do that. I'm then also just going to specify a message, and I'll say the message is, would you like to read subdirectories as well as the root level. And then also, I think from there we can just create our message. So to do this, we're going to use what's called an alert. I use these quite often. So an alert basically looks for a various set of properties, but effectively it's displaying a message to the user with a title and optional sub message. We can then say, okay, false, yes, no, various arguments. And in this case, I'm just going to make it say yes or no. We can see by default, yes is false and no is false and cancel is false, but okay is true. So we want to disable okay because we want it not to be true, but we want to then make yes and no true. All of these arguments are what we call keyword arguments or quags, which means in this case, they don't have to be specified. And they can be specified in different orders, but you do need to specify the name of the keyword argument being provided. So in this case, I'm going to say that the run mode is equal to forms.alert. In this case, we're going to firstly show the message, which we've stored to a variable called message. We're then going to show the sub message, which we have to specify, and I'll just say sub. We'll say title is choose run mode. And I might zoom out just a little bit so we can specify some more arguments. I'm now going to say that okay is false, yes is true, no is true, and we don't want to show a warning icon in this case. And from this, we should be able to show this message to the user. So I can now pick a directory, and we see our sub message, we see our primary message and our title, and I can say yes or no. Now in this case, depending on what I pick, we are going to get particular outcomes. We're going to want to process if we pick no or yes, which would be true or false. If the user cancels, then run mode will be equal to none. So in this case, I can say if run mode is equal to none, then we exit the script. But we don't, in this case, want to use the same syntax as before. So this is a special syntax, if not. So this will also check for a false condition and find a true outcome if it's false. But if it's equal to no value, then the not condition will also detect if something is not true, or none in this case. So what we're going to do now is just say instead that the only condition we want to exit under now is that run mode has to be none, because we do want to proceed with a run mode of false potentially. So the next thing we need to do is actually get all the file paths out of the directory. So for this, there's a lot of different libraries in Python that can do this. The best one that I found is, in this case, a Windows library, in this case for system.io, which is available to Python. And we're going to be using the directory get files method. I'm going to be using the string option, which in this case will take a file path and also a search pattern. So in this case, actually we might not, probably don't need this one. We do need a search pattern. So the search pattern in this case is going to be all about specifying, in this case, the type of pattern that we want to use. So do we want to search all directories or do we not? So in this case, we're going to be providing a search option. I can't exactly remember, I think it's this one here. So we're actually going to want to be using a system.io.search option. So there are some enumerated outcomes in here. One is all directories and the other one is top directory only. So we're going to be specifying one of these two enumeration options depending on the run mode that we just chose. So I'm going to have to import these libraries. So I'll just say libraries for search. And we're going to import the common language runtime so that we can access other areas. So I'm going to say from system.io import, and in this case I'm going to import both the directory class and also the search option enumeration. I'm then going to just make a function to actually get those files. And I'm just going to do this because I do like to use this in other code, and sometimes it's better to build a function so you can just very quickly copy and paste the base code for a very important step to other scripts, and it also makes for more legible code as well. So I'm going to define a function. So I'm going to say def, and I'm going to call my function directory get families. So we're specifically looking for family files. So I'm going to provide, in this case, two arguments, directory path, which is going to be the path we got from before, but we will provide it through the function. And then also I'm going to have an optional argument called deep search, which by default is equal to false. So I find it's better to put deep search as false, just because deep searching can be quite dangerous if you're not aware that you're doing it. The first thing I'm going to do here is just make two variables, file paths and file names. And these will be two lists that I'm going to build using this code. And then in this case, I'm firstly going to check if this directory exists. So I can, in this case, use the property exists to verify if this actually is a valid directory. It should be, because we provided it through Python, but if you use this code in other scenarios, you may sometimes want to run your code through this just to make sure that the code actually does work. Otherwise, you could get an error at that point. So I'm now going to check if we've provided deep search as true. This is where we're going to specify our search option. So I'm going to say mode. I'm going to store mode as a variable. And I'm now going to take the search option and I'm going to enumerate firstly the all directories option. Otherwise, we're going to pick the other option, which is going to be search option, and this is going to be top directory only. From here, we actually want to get our file paths. So I'm going to store this to a directory files, or directory, so I'll say directory paths. And I'm going to use the directory.getFiles method that we saw before, which takes the argument of directory path. In this case, a scan, or I think they call it a scan string or something along those lines. I'll just double check the terminology for it. A search pattern. So in this case, for now, I'm just firstly going to look for just anything with a dot in its name. I could look for .rfa, but I usually put the searching criteria further into the code, just for more obvious reuse of the code elsewhere. And I'm going to specify my run mode as my search option enumeration. And now I'm actually just going to look through the file. So I'll say actually get family files only. So I'm going to say for file path in directory paths, I'm going to firstly check if .rfa is in the path. And then I'm also going to say if .00 is not in the path as my two conditions to pass in order. The reason I'm doing this is I want to exclude family backup files. So I'm going to just use this as an easier way than using a search mode. I think you could use .rfa as a search mode, at the highest level, and then just exclude the backups as well optionally. But sometimes I find it easier just that the user can look at the code and understand, okay, we're looking for families and then we're looking for non-backup files. It's probably a little bit inefficient from a coding perspective, but maybe a little bit easier to read. So I'm now going to say, first of all, that if we found a family file with no backup in its name, then I'm going to say filepaths append, and I'm going to append, in this case, the file path that we found. I'm now also going to get the file name as well. So we're going to store two lists and send these both out of the function, and this will let us cross-index these two objects using either the file names or the file paths that we desire in our code later on. So I'm firstly going to say that the file name is going to have to be at the end of the file path, and we're going to look for the last occurrence of a backslash, I think it would be in this case. I forget if it's forward or back. I think it's a backslash. So I'm going to take the file path, and I'm going to use a method called rsplit, which will split a string from the right by a number of times that we tell it to, or as many times as it can if we don't specify how many times. So I'm looking in this case for this slash symbol, which will be at the end of the file path before the file name. I'm using 2 here because this is in this case an escape character in Python. It's a special type of character, but if we use 2, then this tells Python we're looking specifically for that slash symbol. So that's a little bit of a Python special, that one. I'm just going to do it once because we know that the last thing is going to be our file path. From here, I can also say that from this list of strings that we get, I want to get the last one. So I'm going to index the outcome of that at the end, just to get the piece on the end of the file name. I'm also going to get rid of the extension. So no extension is equal to, and I'll take that file name, and I'll use the replace method. And I'm going to replace .rfa with an empty string, just to get rid of the extension. From here to file names, we can append no extension. And finally, we can return the outcome. So I'm going to return a list containing file paths and file names. So that is effectively the core function for retrieving the family files from that directory that we can use to compare to the families in the actual document itself, and then get the equivalent paths to reload. So now that we've got these, we can then verify, we can actually get the file names first. So I'm going to use a special method here. I'm going to store 2 variables to a function outcome, which I know will yield 2 objects. So I'm going to say in this case, get file paths and names of family files. And I'm going to say in this case, file paths and file names is equal to, and I'm going to use in this case my actual function, which is going to firstly target the directory path, and it's also going to target the run mode as the 2 arguments that I'm providing. And we don't need a colon there. And now we have, so we should have both the file paths and the file names in 2 separate lists generated by the function. I can then check that I actually have any family files at all, because we might have no family files in there, in which case there's nothing to compare. So I can say if the length of file paths is equal to 0, then I can exit my script, and I should probably tell the user why we're exiting as well. So I'll just say forms alert, and in this case I'll just say no family files found in directories. And then the title can just be script cancelled. So if I did target an invalid directory, the script shouldn't bother to proceed past that point. But otherwise, let's try just printing the file names that we do find. So I'll just say print file names. So I'll run my testing script, and I'll target in this case my full directory, so it'll be quite a lot of families. But we can see that I've just went and found a significant number of family files and for their file paths. If we pick an invalid directory, let's say for example that I target maybe just my desktop, or maybe I'll just target the root level. So I'll say no for this, and then we don't find any family files because my library contains no family files at that level. So at this point we've got a fairly important part of our script covered. Now we're actually going to work with our Revit model and target our families. So in this case I'm firstly going to get the Revit document, and families. So I'm going to say the document is revit.doc. So that's an argument pyRevit provides to us. And I usually like to store it to the Word doc because often we use that in non-Python, non-pyRevit code, such as in Dynamo. So it makes it easier to copy and paste and move your code around between those two environments. I'm then going to get the families. I'm going to use a filtered element collector. We use these quite often in pyRevit. I've used them quite a lot, so I won't go into too much depth of it, but I'm going to store this to a variable called families. And I'm going to go db.filteredElementCollector. So we're using the filtered element collector class and using db to indicate to pyRevit this is a Revit API class. I'm going to apply it to the document. I'm going to use the of_class method to filter by the class. So I'm going to call on the family class in this case, again indicating to pyRevit using db that this is a Revit class. And finally I'm going to elements. So at this point we should have all the families, the loadable families, in our Revit document. I now want to actually look for the matches. So find the matches to the files in the directory, because we can only reload from files that actually match the families in the project. And I'm going to show these to the user in a list to pick at the end before we actually go and reload the families. So I'm going to say here that matches is equal to an empty list, and we're going to store all the matches that we've found. So I'll say for f in families, and I might actually go to the family class in the Revit API docs. So I'll look for the family class, which in this case we can see as an element that represents a custom non-system family in Revit. And from this, we're going to be looking firstly at its family category so that we can tell the user the name of the category this belongs to. And we'll also be looking at the name of the family itself, which I believe should be a property that's available. Yep. And we can also get the name of the family as well. And remember, this will be without .rfa, which is why we've taken it out before in our file name. So I'm going to say for each family, and I might just give myself a little bit of extra room here. Zoom in a little bit. So for each family, we're firstly going to get its name and store it to a variable called family name, so we can use this later. But I can now check if this name is actually in the file names that we found before. So I'll say if the family name is in file names, then we know that this is a match. This is a valid candidate to compare and provide to the user in an interface. So I'm firstly going to get the category name of the family. So I'm going to say the family.family category. And then the name, so I'm going to use chaining in this case to ask for the property of the result of that outcome. And I'm also going to make a variable called match and call this category name plus, and I'll do a colon space. And it's important to remember that colon space. We're going to use it later to process the things the user picks from the interface. And then I'm going to add the family name to that. Finally, two matches, we can append match. So this will only store any families in the project that have a valid match in the directory contents that we found of families that we found. So of course, again, we might just borrow this piece of code here, just so we can say if the length of matches is equal to 0, then we know that no matches were found. So we'll say no matching families found in directory/project. And the script would be cancelled. But we are going to have some matches in this case. So if I go again to run testing, scan the full directory and say yes, it's going to find some matches, so we can see that it's going to go all the way through, and now it's ready with that list of matches for us to proceed. So I'm also going to sort these just so they get shown to the user in a good order. So I'm going to say matches.sort. Now it's important to note that when I do this, the order of those matches has no correlation to the families anymore. And to be honest, once I filtered through here and only kept some of the families as a match name, they lose the relationship back to the original family anyway. But that doesn't really matter because really we're just going to be looking for the file paths to load in based on the names that we found. So now that we have these matches, I'm going to use a list, a special list in pyRevit to display them to the user, so that they can choose which families they'd like to proceed with. So if I go back to pyRevit docs, I can look for, in this case, the select from list form. And in this case, we can see that this one will require items and a button name, but there are also some extra arguments that we can provide to this as well. So I'll just try to find the actual, there we go. So we can see we can specify the width, the height, But we can also specify things such as whether we'd like to be able to select multiple elements, which by default is false, so we're going to want that to be true. And in this case, we'll just use this to build a basic interface to show the user. So we're going to say choose which to reload. So I'll just call this reload names, because these are strings, remember. And I'm going to say forms.select from list. And first of all, we're going to show the matches as a list of options to show in the list. I'll say title equals select families. And I'll say button name, and I'll just zoom out, equal to reload. And the most important one, multi-select, has to be equal to true. So now when I run my tool, point to my directory, deep search, we get an error, of course. I must have done something wrong. I think there's a keyword argument that I've probably missed in this case, or I've made an error with. I'll just double check. So we've got the matches, we've got the title, we've got the button name, we've got the multi-select. I think I might have to specify the width. No, I haven't shown it, that's why. So select from list is special. You have to tell this to actually show itself. Just turn off insert and go show, and I think that might fix that error. It's probably in the example in the pyRevit docs as well. There we go. So now we can see we've got a list of matches that the user can pick and filter through. So we can always pick for match strings if we know exactly what we're targeting. Maybe we're only targeting casework, and there's casework. We can also type in casework as the categories there as well, or we can shift select, or we can just select all of them and proceed. And that will proceed to provide those matches to our script. So that's sort of I guess the easiest steps out of the way. We go to a pretty complex step now, and before I do this, I might just say if not reload names, then script exit, just so if we don't pick anything, the script will exit. But now we actually need to reload our families. So in this case, there is a method that we'll be using here. It should be the load family method, which I believe we apply to a document. Just double check if this is it. Pretty sure it has the iLoad options. Yep, that's the one. Once the browser refreshes, cool. So we have the load family available, and I believe that this is applied to the active document, the document we'd like to load this into. Now there are various options that we can use. I believe we're probably looking for, I think we're looking for this one here, which takes a string, which is a file name. That's technically actually the full file path to the family. We're also going to take this thing called iFamily load options. This is what we call an interface, and this is going to help us bypass the overwrite parameters dialog that would show up if a family needs to be overwritten. So this is a special type of object in the API. It's called an interface. Usually you have to wrap this into a custom class when you're using Python, and then specify these methods as methods of the class to tell this object how to basically interact with the actual interface that Revit generates through its own API. So we're going to be dealing with both the onFamilyFound and the onSharedFamilyFound methods, which in this case take a few arguments. Is the family in use? If so, do we want to overwrite the parameter values, true or false? If there's a shared family found, then do we want to do this? And also we have an enumeration for the family source, either project or family. So we can specify these things when we're trying to actually reload these objects. I believe by default that the family source is probably going to use project if I remember correctly. So I'll just double check, but we'll proceed with this anyway. So we're going to start building an interface class. And I'll be honest, I wouldn't have been able to learn this without reference material that does this, to understand how you build classes to provide interfaces with information. So I'm going to say class family option. And in this case, we're going to be calling on the iFamily load options class. So we're going to have to specify that as DB. And within this class, we can now specify functions. First of all, the onFamilyFound function, which acts as a method. So we're going to take the object, which we call self, so the actual class of the family load options. Also is family in use, and also overwrite parameter values. So I believe you have to actually make these read exactly Actually, I don't think you need to make them read exactly as they do in the Revit API. I think they just need to provide the right data back to the API. So for now, I'm just going to specify that overwrite parameter values. I might just copy this, is equal to true. So in this case, this will tell the interface to overwrite the parameter values of the family if it's found, and then we also return true as part of that method. We also want to define on shared family found. This one's a little bit harder. So we want to say self. So we're basically taking the arguments from the API. Shared family. Family in use. Source and overwrite parameter values again. I've probably made a typo in there somewhere, but I guess we'll find out. And we're basically going to take the same things, just to say that we do want to overwrite the parameter values if we find a nested component. Now, we could say no if we wanted to just not overwrite this. And I believe we can also specify the source in this case. So the source being an enumeration. So this will be a family source enumeration. So we want to say in this case that source could also be equal to db.family source dot, and this is where you can specify project or family. So we'll say in this case, actually, we'll say project and see if this works. And I believe that this should work. Just to test it, we're just going to temporarily create a family load option. So I'll just say load option is equal to family option with no arguments, and that effectively will create an instance of that custom class we've just generated to provide something to the interface. So I think it should work, hopefully. So we'll go through our usual steps. Yes, check all. And it looks like that's worked. So I think we should be able to use that as a valid provider to the interface that would usually appear when a family is going to reload. So I think that's a much better option than having to see the interface every time something needs to be reloaded. But of course, you need to make sure that that is how you want your families to be reloaded. Generally, I find that you're usually going to want to do them one way, so that will typically work. I'm also just going to make a class to load family as well, and this is really just to make the code a bit more legible because we're going to be working in a loop structure. So I'm going to define family reload as a function instead of a class, of course. So we're taking a file path and we're taking load options and we're finally taking a document. So I'll say my document, and if there's nothing provided, I usually say revit.doc. I like to do that just in case the user doesn't want to specify the Revit document. We will of course provide the document that we've already generated once in our code earlier, just for efficiency. So in this case, I'm just going to try to reload the family, and if it fails, I'll report that back. So I'm going to say try, and in this case, we're going to be using that load family method that we've found. So we're going to apply it to the document, which we're calling mydoc. So we're going to do that load family method, and we're going to provide the file path and the load options, which in this case will be an instance of these family load options. Now, if that worked, I'll return 1. Otherwise, I'll return 0. And we're going to use this to uptick a variable, which we report at the end to say how many families were successfully reloaded. So I believe that's all we should need to do in that step. So what we're going to do now is just load the family files. So we're going to do a few things here. As we load the families, we're going to be presenting a progress bar to the user that can be cancelled. We're going to be working with a Revit transaction, and we're also going to be using these family options and the family load function, and we need to find the matching file path from the names that we've generated in our options that we gave to the user. So a few steps there, a little bit complicated, but we will get there. So the first thing I'm going to do at the highest level is create a progress bar. So we use these in a few videos, but we're going to do the with statement to do everything inside the statement with a progress bar. I'm just going to say the step is equal to 1. The title is going to be something special. So I'm going to use, in this case, reloading families. But I'm also going to report how many we've progressed through. So I'm going to add to that value of, so I'm using formatting strings here, max value. So these are special values that the progress bar can draw out of itself to report these back progressively. So So this should create a dynamic progress bar. I'm going to say that cancelable is also going to be equal to true. So we can actually cancel our progress bar if we want to. And I'm going to call this PB1 or progress bar 1. So I'm now going to actually work with the progress bar. So I'll begin just by setting the progress bar properties. So we're going to say what is the total of the progress bar, and I like to usually put a number after these in case I use multiple progress bars in my script. And I'm going to check the length, in this case, of my reload names. How many things are we trying to reload? I'm going to start at a count of 1, just to show that we are reloading a family when we begin. So I'll say that's 1, and then I'll just say pbworks is equal currently to 0. And this will be the variable that we use to check how many objects were successfully reloaded. I'm now also going to just create family load options. So I'm just literally going to take a family load option and store it to a variable called load options. And we're going to use this later on when we're loading our families. From here, I'm going to actually create a Revit transaction, but I'll just try to actually reload the families themselves within that transaction. So again, with transactions in pyRevit, you can use the with statement, and from Revit, we're going to call on its transaction class in pyRevit, and we'll call this reloading or reload families. And we've got our reload options, so now we're gonna actually say for each family, reload it. So we'll say for, in this case, we'll store the reload name as a variable called rn, and we'll say in reload names. So we're doing for each reload name. The first thing is we want to make sure progress bar isn't cancelled. So we do want to be able to progressively check that. So I'll firstly say if progress bar 1 has been cancelled, then we're going to break. So break effectively will stop the loop from running. But obviously if it hasn't been cancelled, then we want to keep going with an else outcome. And the first thing we actually need to do is check what the file path is for the family name that we've matched. So I'm going to firstly say that the family name, remember that the family name at the moment, or the matching name, is actually the category plus a colon and a space plus the family name. So we want to break that family name part back out of the match and then look for it in our original list of family names from the directory, and then say wherever you occur, tell us what your file path was. So in this case, we'll say family name is the reload name dot, and we'll use rsplit again. And I'm going to split it at the colon space, and I'm going to do that once. And again, we're going to take the last piece of the list of strings that are generated from that to get the family name on the end. Okay, then in this case, say that the index that we know that's going to occur at as a file path is going to be equal to the file names that we got before from the directory, dot index, and we're looking for family name, which we know has to be available in that list of options because we got it originally as a match anyway, so it has to be there. Finally, we can say the file path is going to be equal to file paths indexed at that index. So now we should have the actual file path to reload. So all we need to do with that is actually just say that we want to reload the family. So first I'll say family reload, and we're going to provide the file path that we just got. We're also going to provide the load option that we created before and the document that we got a fair while ago in our code. Now this is going to return 1 if it works or 0 if it doesn't. So what we can actually do is take pbworks1 and plus equal the outcome of running that function. In this case, the function, if it returns a 1, will make pbworks the same as itself plus 1. That's what the plus equals syntax means. So it's a little bit of a shortcut where you don't have to run any extra logic to increase the value of the variables. We don't have to say if it worked plus 1, if it didn't, don't do anything. Instead, we just add the outcome of the function. It's a little trick I use quite a lot, and it's quite useful. So the last thing we actually want to do now is within our looping structure, we want to update the progress bar. And to do this, we can say progress bar 1 update underscore progress, which is a method that pyRevit provides. And we're going to firstly say that we want to set this as the count and then the total. And after that, we're going to take the count and we're going to plus equal 1. So we're going to raise the count by 1. So as each loop proceeds, the progress bar will increase by 1, as long as we haven't cancelled the progress bar. So we might actually just also, before we run this script, because I'm pretty sure this should work, we're just going to report the outcome to the user to tell them what actually happened when it finishes. So we're going to create a message, and I'm just going to store this as a variable just to avoid making an alert too wide, because we're just going to show an alert to the user to tell them what happened. So I'm going to turn into a string the amount of objects that worked. So PB works 1 plus, and I'll do a little slash, plus the total number of elements. So how many out of the total actually worked. And I can say families reloaded. So this will give us a little message telling us how many worked. And then I can show a form to the user, message, and the title I'll just say is script completed. And we're going to see this regardless of whether the progress bar finishes or not, because it will break the loop, but it will still finish running this and then get to the end. And then we're going to also say that we don't want to show a warning icon. And I think this should work. There might be a typo somewhere. It often happens when I write pretty long Python scripts. But let's just try, first of all, just modifying a family to verify that this works. So I'm going to go and just delete, in this case, a piece of the family. And then we'll do a reload. We'll reload everything that we find, but then we'll verify just based on one of the families that it likely worked. So I'm going to hit my testing button, point to a directory. I do want to read subdirectories. I found my matches. Let's actually just first do one. Maybe we'll just do 4 of them just to keep it small. Okay, I've got an error. So form, I've made a typo right at the end. Where's my form? Line 96. So it's up here. Forms, progress bar. There we go. So there we go. One typo. So we'll just run that again. I'll just do all my casework. Here we go, error, load option. I think I have to do load options. Just double check. Load options. I think I didn't say load options. Okay, let's try again. Always a couple of typos. It's always typos. Okay, let's just select a few of those. Hit reload. This is looking promising. We can see 2 of them were very quick because there wasn't any changes to be made. We can see it probably took a little bit longer on that one that probably hopefully got updated. And there we go. Now we can see it's loaded in all these types. Obviously we can purge them out at the end. I'm not aware if there's a way for it not to load the types, because usually that process is guided by a type catalog that the user interacts with. And I don't believe the API can do that. But we can see that in this case, we should have successfully, reloaded our cupboard. Excellent. And I can also, in this case, just run a full reload as well. Test tool, and I'll just pick literally everything I can. We'll see how long it takes, because there's quite a lot of things to reload here. In this case, we can see there's 50, but it's quite quick. It's progressing quite fast. And I didn't have to find the location of any of these families. Now, of course, it may not have found every single family. Some families might have different names, or they might have changed in the project. In this case, you could also build your script to report any families that didn't find a match in a separate report after if you wanted to. But otherwise, this is a really quick and efficient way to refresh all the families in a project if you're working with a Windows directory and you know that those families are accounted for in the outcome of running such a process. So it's almost finished. But otherwise, it's a very efficient and nifty little tool. I've already started using it on a few projects because I found it quite useful. But here we go, 50 out of 50, done. So we just refreshed 50 families in the project, didn't have to find them, didn't have to click reload from. It saved a heck of a lot of time. So hopefully that's a useful workflow. So I think I've got my presentation, there we go. So if you're not already following and subscribing, feel free to do so. I've got all my stuff over on GitHub, including this script. So do check it out if you do need a copy. And if you have any queries or suggestions about this workflow or request, feel free to leave it down below as well. I do try to address any that are relevant to my skill set, and I'll let you know if they're not and where you might be able to find out more information about them. So I hope that was useful, and it's a useful tool, a useful exploration of pyRevit. I look forward to seeing you in future similar videos. Thanks. Take care. Bye.